So now in this video we're going to look at the NPN bipolar junction transistor wired as an emitter follower. So basically it's a voltage follower. Here is our signal. It's going to the red jumper, going to the channel A oscilloscope probe, which is the yellow line. So you can see that. Now you can see right below it, that is the output of this circuit. So that's the emitter of the bipolar junction transistor. So between these 2 points is the base to emitter. You get a 0.6 volt drop. But otherwise, the voltage is following, and that should be 5 volts coming in, even though it looks a little bit low right there, and somewhere about 0.6 or so volts lower right there for our voltage across the load. So it's a voltage follower, but since there's the base to emitter drop, it's an emitter follower. And here is a diagram I put together. So main takeaway is, we have a weak input voltage. That's what the trim pot is. So this is a 10,000 ohm trim pot. Right now, when you set about halfway, there's about 5,000 ohms towards the positive supply there, about 5,000 ohms to the negative supply, outputting about 2.5 volts approximately. So if we were trying to put that voltage across the LED, you need a significant amount of current to light up the LED. Even if I set it here, we got, maybe 2,000 ohms of resistance, maybe even 3,000 through there. That LED would not be near that bright if it had to go through there, and it would lower the voltage over here. So that is what the bipolar junction transistor does. When you set the voltage there, it's going to try to make its way to ground, and thus current's going to start trickling through there. Now, as I said before, if you ask for current out of a trim pot, that's going to throw off its voltage. So the little trickle won't though. So once current starts going, current's going to flow through collector to emitter much more so, like 200, 300 times as much current. And therefore, this will build up the voltage. As current goes through here and starts going through the loads, the voltage will build up. Once it gets to 0.6 volts less than the base, then the base won't be passing any more trickle of current. It'll be steady state, as well as the collector to emitter right there. And that's how you hold the voltage. Hopefully that makes sense. So for this circuit, again, 10,000 ohm trim pot. There you can see the voltage across it and the wiper that slides along there. And we have 10,000 ohm. That's the most common value I see for emitter coming to ground there, just to help the emitter see where ground is. As I said before, some loads may throw that off, especially if they drop voltage or stuff. And then at that point, we just have, like 1.52 volts that the LED drops. The rest of the voltage that is at the emitter goes across the resistor there, and it sets the current.